we tend to think that we are first. Okay, so we are the first to develop advanced technologies. But that may not be true. There may have been, if you go back 100 million years, 200 million years, there may have been a civilization that is fairly advanced, and then there was some catastrophe like a meteor impact, an asteroid impact, like the one that killed the dinosaurs, right? So if there was a major extinction event, it would have destroyed that civilization if it happened hundreds of millions of years ago. And by the way, 200 million years ago, that's just 5% of the age of the Earth. I think completely plausible that intelligence could have emerged or technology could have emerged earlier, by 5% earlier. And it would be difficult to find the remains, the materials, the buildings, the digital screens, whatever they produced.
Hello, everyone. I would like to introduce you to Harvard astrophysicist Professor Avi Loeb. It's a pleasure and an honor to have you on the program. A warm welcome, Avi Loeb.
Thanks for having me. It's a great pleasure. And in fact, I was not far from you visiting the Niels Bohr Institute in Copenhagen just a couple of weeks ago. And right. I should say that it was refreshing because when I entered the auditorium, it looked familiar, even though I've never been there, from a photograph taken 95 years ago of Niels Bohr sitting next to Werner Heisenberg and Wolfgang Pauli and Lev Landau. And that's
kind of heavy,
where quantum mechanics was born. And even though, the one thing I thought about when I sat on a wooden bench in that auditorium was how uncomfortable that wooden bench is, and how life back then was not so such a high quality of life as we have today. But I would trade everything I have to go back 95 years, because the mindset of those physicists was open-minded. They were willing to replace our view of reality, the physical reality, by something completely new. And indeed, the auditorium delivered that spirit. During the conference that I attended, people were very interested, including a Nobel laureate, David Gross, very interested in discussing 3I Atlas, the new object. In fact, I wasn't planning discussing it. I had a talk about black holes, but they wanted me to discuss it.
Of course, that's the most topical thing right now. So let's start with that. Let's kick off there, because dive right into it. Because as we speak, an interstellar object is hurling through our solar system. 3I Atlas, as you mentioned, as it has been named, isn't just any old comet. Or what is it? What is it about this object that piques the imagination and the interests of observers like yourself?
Yeah, I should start by saying that science is fun, and the fun originates from the fact that it's a learning experience. We should not assume that we are the adults in the room. We know the answer in advance. It's not about that. It's not about showing off. It's about attending to unusual data, unusual evidence, because the only way for us to learn something new is from anomalies, things that do not line up with our narrative. And with respect to this object, 3I Atlas, it was discovered by a telescope called Atlas that surveyed the sky from Chile. And it was relatively bright because this telescope is 0.5 meter in size, and it detected the object on July 1st, 2025. And as soon as the discovery was made, I heard about it because I had to wake up at 2 a.m. For a radio interview. And one of the listeners emailed me about it. And the first thing I calculated was the expected size of the object. And turns out that, if the brightness of 3I Atlas originates from a solid surface reflecting sunlight, it has to be tens of kilometers in diameter. And most recently, the SphereX Space Observatory did detect the reflection of sunlight at a wavelength of 1 micrometers, and estimated that if it was a reflection from a solid surface, then the object needs to be 46 kilometers in diameter.
Wow.
Which is twice the size of Manhattan Island. That's huge. And it's 1 million times more massive, if it's a rock, 1 million times more massive than the previous interstellar object that was discovered in 2019, 2I Borisov. That one was definitely a comet of a very familiar type. But why would we see a rock that is 1 million times more massive? You should expect millions of objects like Borisov before you see one giant rock. And I did a calculation and submitted it for publication that shows that there is not enough rocky material in interstellar space to deliver once per decade such a giant rock. We should have waited for tens of thousands of years before we would see one such a giant rock. Now, of course, there is an alternative, and the alternative is as I mentioned in my paper, just written a couple of days after the discovery, that in fact the object itself has a diameter of less than 1 kilometer, much smaller. And what we are seeing is the reflection of sunlight from a dense cloud of dust around it. But the problem with that interpretation is, if that were the case, dust particles that scatter sunlight have a size comparable to the wavelength of sunlight, which is 0.5 micrometer. And such dust particles will be pushed very quickly by radiation pressure from the sunlight and will be moving away from the sun and establishing a cometary tail. That's what we see around comets. The reason comets are called comets is because we see a tail oriented away from the sun. There was no such tail observed in July and August. Only recently we are starting to see some kind of scattered light behind the object. And that's more than 2 months after the discovery. And moreover, the Hubble Space Telescope obtained a very high-resolution image, the best image we have, of this object. And I analyzed it most recently and posted a paper about the analysis just a few days ago. And there is definitely no tail in that image from July 21st, 2025. What you see is that starting at the center where the object is supposed to be, if you go sideways, you get the same extent of the glow of scattered light as if you go backwards away from the sun. But if you go forward, then you see that the reflected light glow is actually twice the length of these other directions. So in fact, there is a glow preceding the object towards the sun, opposite. We've never seen that before. Usually we see a tail. This time it's something ahead of the object, and it's twice as long as the width of the glow sideways. And in fact, the projection is very unfavorable because the object is almost, moving towards us and the sun. It was observed at a large distance, 3.8 times the Earth-Sun separation. So if you correct for the fact that we are looking at it almost edge on, as it's because the sun and the Earth are roughly at the same direction from the object, they are separated by 10 degrees. If you correct for that, you find that the extent of the elongation is 10 times the width of that glow. So in other words, it looks more like a cigar that is 10 times longer than wide. This glow of scattered sunlight, why would you get such an elongated glow in the opposite direction than you see for comets? That's one of the anomalies, in addition to the size anomaly. Yeah. And then here comes another anomaly that for me was actually quite remarkable, that the object is traveling in the plane of the planets around the sun to within 5 degrees. And the previous object, for example, Borisov, was at a large angle, as you would expect from a random arrival direction. But this one, if you were to design a spacecraft that will visit the planets, you would let it go in the plane of the planets. That's where 3i Atlas is. And the chance of that happening at random is 1 in 500. So that is extremely unusual. That's another anomaly. Then we have data on the plume of gas around it. And all the experts were saying it's a water-rich, dusty comet, And as I explained, it's not very dusty because we don't see a tail. And if you ask what is the composition of the gas around it, the Webb telescope and the SPHEREX Space Observatory discovered that it's made mostly of carbon dioxide, 87%, and the 9% is carbon monoxide, and then water is only 4% by mass. So apparently it's a very unusual composition. But even more startling is the discovery by the very large telescope in Chile of nickel in that plume of gas without iron. And nickel usually comes with iron in all the comets that we know about, in nature in general, because nickel and iron are produced by exploding stars, and they have similar quantities, and you wouldn't expect to have nickel without iron. The only place where you find nickel without iron is in nickel alloys that are produced industrially, manufactured technologically. And so we only have an upper limit on the iron, and we detect very clear nickel signal. And so that means that somehow there was a process that allowed nickel to exist without iron, and perhaps it's, the surface of this object was manufactured technologically, who knows? So that's an interesting anomaly as well. And then we see also cyanide, and both cyanide and the nickel are growing in abundance very rapidly, and it's not clear why, because they are, as a function of the distance to the sun, they are growing inversely with distance to the 9th power, extremely fast. And so we don't understand these details. And then, of course, the fact that this object comes, in the plane of the planets makes it very unusual, because it will come close to Mars and on October 3rd, 2025, and then very close to Jupiter on March 16th, 2026. And that is also an opportunity, because we have space assets. We have orbiters around Mars and orbiters and a spacecraft around Jupiter that is called Juno. And we can use those to, for example, there is a camera called HiRISE on the Mars Reconnaissance Orbiter that could resolve 3i Atlas when it comes within 29 million kilometers on October 3rd. And it could get a pixel resolution of 30 kilometers. So it would be able to constrain very tightly the size of the nucleus. So that would be very exciting, and I'm waiting for that. October 3rd is not very far away. And then I also wrote a paper suggesting using Juno, the spacecraft around Jupiter, to probe 3i Atlas when it comes close to Jupiter on March 16, 2026. And a day after I wrote the paper, I had a phone call from Congresswoman Anna Paulina Luna from the US Congress, who wanted to get an update on 3i Atlas. And I mentioned the opportunity that NASA has, and she wrote a letter to the head of NASA encouraging NASA to use all these facilities at its disposal to learn more about 3i Atlas. Finally, the last anomaly that I should mention is the polarization of the light that was detected from 3i Atlas. It's unusually extremely negative relative to all the comets or asteroids that we have found. And maybe that's related to the fact that there is this plume of scatterers of sunlight ahead of the object. That's unusual geometry. 10 to 1 aspect ratio may have triggered this unusual polarization. But, it's really interesting because if I look at all the papers that were written, and there were dozens of papers, I myself wrote 9 scientific papers over the past 2 months about the 3i Atlas. And if you look at all the rest of the papers from the literature, dozens of them, they always try to explain it as if, it's a comet with variations, but things we are familiar with. There is nothing unusual about it. Even if the trajectory is aligned with the planets, okay, weird things happen, shouldn't worry about it. It's supposed to be water rich, but it's showing carbon dioxide. Okay, so it formed in a place where there was carbon dioxide ice. Nothing really dramatic about that. It has nickel without iron. Who knows? Maybe there is a process similar, the carbonyl pathway that we use in the industry to produce it, and nature knows how to do it. Nothing unusual. It always reminds me of the statement in the Old Testament where Ecclesiastes was saying that there is nothing new under the sun. Okay, and I completely disagree with that. I think there are many things that could be new under the sun, and 3i Atlas is one of them. And let's examine it. And even the sun will not exist in 7.6 billion years. So clearly that statement is incorrect. That there is a lot of new things that are happening under the sun, and we should remain curious. And the one reason I'm advocating that 3i Atlas could be technological is because then I encourage my colleagues to take as much data as possible. So even if it's a rock, we will learn something new about rocks that arrive to our backyard from another star. And by the way, this opens a new window in astrobiology. That's something I thought about as a result of 3i Atlas. Because imagine that we had an interceptor, a mission that would land on 3i Atlas, bring back 100 grams of materials to Earth, as we did with the asteroid Bennu, and we were to examine this material. For the asteroid Bennu that was part of the solar system, it was found over the past year that most of the amino acids that are the building blocks of life existed on the asteroid, on this rock.
That's fantastic.
And so the question is, if we examine a rock from another star, does it have the same building blocks of life? It's a very different approach than the current thinking of the mainstream of astrobiologists, and they are willing to invest more than $10 billion to look for the molecular fingerprints of life in the atmospheres of exoplanets around other stars. So that's remote observing. Just look, but having a sample of material from another star, if we were to do it ourselves, it would take millions to billions of years to go back and visit stars in the Milky Way galaxy, whereas the billions or millions of years were already spent by an object like 3i Atlas, if it's natural. So we should take advantage of that and examine it. And I see that as a new opportunity for astrobiology. And nobody else is recognizing that, but to me, it sounds like an amazing opportunity. But of course, if it ends up being technological because of all the anomalies that I mentioned, then we will know that not only there is life somewhere else, but there is intelligent life.
Yes, let's dive a little bit more into that. You're already mentioning this thing that it might be technological, because firstly, this is only the third interstellar object that we have detected, right? So far,
yes.
Over the course of 8 years. I suppose there have been many before that, but we weren't able to detect them. Is that correct? Or?
Oh, no. I mean, there are objects like that all the time. It's just that over the past decade, we had the first survey telescopes that could survey the sky, and we had the software that can go through the data and discover interstellar objects. These are objects that are moving too fast to be bound by gravity to the sun.
Yes, I understand. And most of the rocks that are out there, they're from our own solar system, so to speak.
Well, yes,
but most people aren't aware that there is a difference there. But
Yeah, so we obviously detected in the past a lot of rocks, asteroids or comets from the solar system. The thing to keep in mind is that if it's not a comet, if you have an object that is like a rock, an asteroid without ice on it, so it doesn't produce a cometary tail, then it needs to be big enough to reflect enough sunlight for the telescopes that we use to find it. And so that implies that only rocks bigger than about a football field, a soccer field, 100 meters or so in size, only bigger rocks can be detected at roughly the Earth-Sun separation. And the main motivation for the discovery of the first interstellar object, which was found by the Pan-STARRS telescope in Hawaii, was to design a survey that will find near-Earth objects because they pose a threat to us. So there was this congressional mandate to NASA to discover 90% of all the space rocks bigger than a football field, bigger than 140 meters or so, that may come close to Earth. And that telescope in Hawaii was surveying the sky, and then it noticed an object of that size, roughly. But
yes, so that was in 2017, and the first one was called One Eye Oumuamua.
Oumuamua, yes.
And you yourself, you rose to fame, if we want to call it that, when you already then started speculating. You had these bold speculations about this object perhaps being technological, as you say, because of the way it behaved, because that one also behaves strangely, somewhat in the same manner that 3i Atlas is
very different. The anomalies of that one were very different.
Okay, but can you elaborate? What is it that makes you open to the possibility that these things could perhaps maybe have been constructed by some non-human intelligence? It's a bold claim to make from a Harvard astrophysicist. I'm sure it's not very popular in all quarters.
Well, but you see, science is not a popularity contest.
I know, yeah.
I don't care how many likes I get on social media. I just try to...
That's why we like you so much.
Yeah, and I should say two things. One, that... we should consider all possibilities until they are ruled out by data, and we should use our imagination, because very often nature is more imaginative than we are, and we should attend to anomalies because they could unravel something new. And the other thing is, of course, I was asked, am I doing this in order to, since you are from Sweden, am I doing this to get the Nobel Prize? And I said, not at all. If I discover evidence for extraterrestrial intelligence, I would not waste my time in traveling to Stockholm. I will try to figure it out, because an award given by a person to a person is much less valuable than information about our cosmic neighbor. The question, are we alone, is the most romantic question in science, and it's as consequential to our future life as finding a partner. It's really, and Enrico Fermi, a Nobel laureate, a famous physicist in 1950, was discussing extraterrestrials with colleagues, physicists in Los Alamos, and he asked, where is everybody? And if I was next to him, I would say, Enrico, don't be so presumptuous. This is a question that every lonely person asks. And what you tell a lonely person is, you are not that attractive. Don't think that everyone will come to you. You need to go to dating sites. You need to look through the window of your home to find a partner. And Enrico, he was an experimentalist. And he did not build a telescope to look for them. He did not search for interstellar objects. And that was his mistake. I mean, just asking, of course, during lunch, you're allowed to say whatever you want. But if you seriously contemplate a possibility and you want to discover whether something exists or not, you need to invest resources. And I say, extraordinary evidence requires extraordinary funding. So very often people say extraordinary claims require extraordinary evidence, but what they're doing is not seeking the evidence. They just say, we don't have extraordinary evidence, therefore we shouldn't contemplate possibilities. And I say, in order to get the evidence, you need to put time, effort, and you need to allow yourself to be open-minded. And we will not make discoveries unless we are open-minded. The science is just like maintaining your childhood curiosity. You have to allow yourself to make mistakes. It's a learning experience. And in the context of Oumuamua, I was just paying attention to the anomalies, which were very different from 3A Atlas. Basically, the object was tumbling every 8 hours, and the amount of sunlight reflected from it was changing by a factor of 10 as it was tumbling. And that meant that it has a very extreme shape. Just imagine a piece of paper tumbling in the wind. The area that is projected in front of you will change. And it's really not easy. Even if you imagine a very thin piece of paper, it's not easy for the area to change by a factor of 10 unless you can see it sideways mostly. And the analysis of the light curve of Oumuamua, this first interstellar object, and by the way, Oumuamua means a scout in the Hawaiian language. That's where the name came from. So the best fit, and there is a very detailed paper of many pages long that tried to fit the data and found that the best fit is that of a flat object, pancake-like, like a disk, which is very unusual for a rock with very large axis ratio of 10:1 or so, and that's unusual to find. And moreover, a few months later, there was a report about the object being pushed away from the sun. So there was no non-gravitational acceleration that it exhibited. But attempts to detect any gas or dust around it failed, even through deep observations by the Spitzer Space Telescope. So it was definitely not a comet, because we didn't see cometary gas or dust around it.
It was kind of flashing then, if it was rotating, as you say, like that?
No, because it's 8 hours rotation period, which is not very unusual, and you would see evidence for the gas irrespective of the rotation if it existed around it. And there were no carbon-based molecules around it, and no dust for sure, because dust you can see because it reflects sunlight. So the question was, what is pushing it? And I suggested that it's just a thin object that is being pushed by reflecting sunlight. And actually, 3 years later, there was another object discovered by the same telescope in Hawaii that was given the name 2020 SO. It was discovered in September 2020, and it definitely exhibited an excess push from the sun by radiation pressure. That was my proposal for Oumuamua. And then a few months later, they detected the spectrum of this object, and it was consistent with an aluminum surface. And then they realized this object actually came from Earth, and it's the upper stage of a surveyor mission to the moon that NASA launched back in 1966. So they traced it. And the only reason they could do that is because we produced this technological object. It was mostly hollow, and sunlight was able to push it because it had thin walls. The fundamental question from my perspective is, who produced Oumuamua? Yes. Now, compare that to the mainstream view. If you were to ask comet experts, actually just less than a year ago, 9 months ago, there was a paper published by a collection of these comet experts, and that's many years after Oumuamua was discovered. We're talking about 8 years later. And these comet experts are saying it's part of a population of what they call dark comets. Now, what is a dark comet? It's a comet where you don't see the cometary tail, but you see that the object has non-gravitational acceleration. So then you could call a spacecraft a dark comet.
Yeah.
Right? And, it's just like looking at an elephant, and that everything you saw in the past are zebras. Then you look at an elephant and you say, oh, that's a zebra without stripes. But you completely forgot that the stripes are the definition of a zebra. So if you see a comet that has no cometary tail, what is it? maybe it's not a comet. So why are you calling it a dark comet? That is an oxymoron. And it's not done innocently. It's done because the experts want to shove the anomalies under the carpet of traditional thinking. They want it to be a comet. They call it a comet. There is no tail. They call it a dark comet.
Yeah.
And that is, in my book, that is cheating, because you have to be sincere. I feel like I'm the kid in Hans Christian Andersen's tale, and I say the emperor has no clothes because this comet has no cometary tail. Therefore, that there is nothing around it. And the adults in the room, they pretend to know everything, and they say, "Oh, of course there is a tail. You just can't see it."
Yeah, dispersed, nothing to see here.
Well, there were models of a nitrogen iceberg where we can't see the nitrogen, or a hydrogen iceberg where we can't see the hydrogen. And we've never seen a hydrogen iceberg, never seen a nitrogen iceberg. And these were adopted as mainstream conservative solutions. To me, it's not conservative to discuss something we've never seen before, and so why not keep on the table the possibility that it's not a rock, which is basically what I'm saying. And the only reason that as you mentioned, I got some fame, or people around the world know about me, is I'm trying to say what sounds to me like common sense. I'm not trying to be different, but the fact that common sense is not common makes me distinguishable. And sometimes I wonder, why am I seeking higher intelligence in interstellar space? And one possibility is because I don't find it in academia.
That's very, very well put. So tell us about the Loeb scale. It's now called, I don't know if it had that name from the beginning, but it's named after you, the Loeb scale, which is relevant in this discussion about Atlas, 3i Atlas and Oumuamua.
So I wrote by now probably close to 60 essays on medium.com about my
fantastic essays. I will put the link in the description.
Yeah. Describing my thoughts as we discover more data on 3i Atlas, because I find it fascinating. It's a detective story. Let's see, we get more clues. We can learn more about the anomalies. And by the way, the public is fascinated. I have more than 1 million readers, to my essays over a period of a month, and that's a factor of 10 more than I had before 3i Atlas showed up. And I got an email, for example, from a former pilot in the US Air Force who said, because of you, and that was the title of the email. And then he said, because of you, my daughter is now fascinated with science. She heard you speak on television, on the radio. She wants to become a scientist, and she keeps talking about aliens. And I had an interview with a reporter from the Times of London. And after he wrote his article, he read it to his children. And he said, now they're fascinated with science. Now, the way I see it is an opportunity to, show that science is exciting to the public. Because just think about it. Very often what happens is you have those scientists in a press conference telling the public what they should know. And it feels like a lecture in a class. Like you're telling the students what they need to know. You're not allowing them to challenge you. You're not allowing them to be actively engaged, to see how the process of learning is happening. You are just saying, I know the answer, and this is what you should know. And there is a sense of superiority, intellectual superiority, which is conveyed this way. And that's why the public feels that science is the work of the elite, or that the scientist feels superior intellectually. And I think that's bad. There is also the sense of don't dare to think outside the box. And, the kind of critics that attack me, some of them have not published a single scientific paper over the past decade. They're called science popularizers. Actually, the Wall Street Journal just had an article about them. And they claim to protect science. Who are they protecting it from? From a scientist like myself who is doing the work in the trenches when they haven't published a single scientific paper over the past decade?
Who are these people? Can you name any of them? Or
Yeah, I can name many of them.
Other groups that.
No, each of them wants to get as many views as possible or to be liked. So I'll give you one example. There is a YouTube person. He produces videos on YouTube, and he calls himself Professor Dave.
Mm-hmm.
Okay, now you check his record. He has never been a professor. He doesn't practice science. He's just talking about science. And he produced a video trying to say bad things about my work when I actually published scientific papers. I published 9 books on science, 3 of which are textbooks. I published more than 1,000 scientific papers throughout a career of 4 decades. I've been the chair of the astronomy department at Harvard for 9 years, the longest serving chair. I chaired the board on physics and astronomy of the national academies in the US, and I was a member of the President's Council of Advisors on Science and Technology in the White House. And, I chaired also the Starshot project, that aim to visit the nearest star within our lifetime. So I have a long resume of both scientific work, and I'm still active. I see science as a lot of fun, and the only reason I did these leadership positions was to improve my immediate environment. But fundamentally, I'm really excited about collecting data and trying to understand what it means, okay? And then there comes this YouTube blogger, or whatever you call it, influencer, and he criticizes me like, how dare he? It's like these movie critics that never produced a movie in their life, and they have critical remarks. When producing a movie is a lot of work. Doing science is a lot of work. And he intervenes, claiming that he's protecting science. So that's an example. But then you have people who are more respectable, people like Neil deGrasse Tyson. Again, did not publish a single scientific paper over the past decade. But he's a science popularizer, and he's usually very responsible. And the issue with his approach is that he looks at what the scientists are saying, most of the scientists are saying, and he is trying to reflect that so that he will be liked by the practitioners of science.
The majority view, not the
anomalies. The majority, exactly. So if we were living 400 years ago, he would side with the Vatican, that the Earth is at the center of the universe, not with Galileo. And so my issue with those people is they don't understand that many times over the history of science, the discoveries were underappreciated when they were made. And only in retrospect, it becomes obvious, So the Vatican in 1992 admitted that they were wrong, that Galileo was right. That was 350 years after Galileo died. It was the worst public relations stunt that they could have made, to admit that for 350 years, they put Galileo in house arrest, and they insisted that the Earth is at the center of the universe. At some point, it became impossible for them to continue to argue that, because we had images from spacecraft. We visited the moon. We could see that the Earth moves around the sun. And by the way, here is the breaking news. The Earth moved around the sun for 4.54 billion years before the Vatican even existed. So did it change anything? No. People can believe in whatever they want. Nature is under no obligation to help us figure out the truth. Nature doesn't care if we are completely ignorant, if we don't understand it. The Earth continues to move around the sun. Who cares what the Vatican says? But humans take a lot of time to realize what the truth is. And, if we insist that everything in the sky is a rock, even though we produce space objects technologically, but we are not willing to admit that someone like us existed near other stars for billions of years before us. If we don't admit that, and we maintain our ignorance, and every anomaly that we see from interstellar objects, we shove under the carpet of traditional thinking, it will not remove our neighbors. It will not mean that our neighbors do not exist. It will just mean that we are ignorant, we are not intelligent. That's all.
So what about this Loeb scale?
Yes. All right. Sorry for the detour.
You lost the question because you were so engaged in this.
So a couple of weeks after 3I Atlas was discovered, the fundamental question in my mind, given the anomalies, was whether it's a natural object, a rock, maybe an icy rock, or a spacecraft. And of course, there are many ways by which you can tell the difference. For example, a spacecraft could maneuver. It has propulsion. A spacecraft might have artificial lights. It doesn't only reflect sunlight. Or a spacecraft could transmit or broadcast signals. So, in principle, we can fly by the object, take a close-up photograph that will inform us beyond any doubt whether it's a rock or a spacecraft. So there are ways to tell. And I said it's about time to establish a scale that is now called the Loeb scale. And there are already 2 scientific papers about the Loeb scale. And 0 would mean a natural object, and 10 would mean an artificial object, technologically manufactured by some alien civilization that could pose a risk to humanity. So that's why it's 10, because
a risk or hope, perhaps.
Well, it's a blind date. It's like going on a blind date. You don't know who the partner would be, and of course you can hope that the partner has good intentions, but it could also be a serial killer. I don't know if you went on any blind dates, but that's always a risk. I met my wife on a blind date, and fortunately, she still has very good will, and we are still married. But it doesn't always end well. We know of many examples, like the Trojan horse experience, right? It looked completely innocent, the Trojan horse, and ended up being quite hostile.
So where on the scale are these interstellar objects that have been detected so far?
Yes. So Oumuamua, I gave it a 4. And by the way, I have a very quantitative definition of what 1, 2, 3, 4, 5, 6, 7, what they mean. 4 means that we don't have conclusive evidence that it's likely to be technological. So we don't have a clear signature, but there are anomalies that make it very different from the objects that we know about, familiar objects. And so I gave Oumuamua a 4, and I gave this object, 3I Atlas, a 4. Now, as we get more data, 3I Atlas may drop down to 1, maybe. I will not give it 0 because the trajectory is aligned with the planets, and that will never go away. And the question is why? Even if it's a rock, it could have been a rock that was sent just to check how we respond to it. That was sent from by someone
as a crude probe or something.
Well, you never know. There might be something inside, or they want to test us and see if how we respond to that.
When we will know for sure what it is and where it will end up on the scale, because it's coming close. It's coming to its perihelion in late
so it will
October
come. It will come closest to the sun on October 29th. And someone texted me on my phone saying that he is investing, trading against the volatility of the market with an expiration date of October 29th, just in case it might be technological, because he can make money out of that. That's also, cool. A couple of days ago, someone sent me a place where people are gambling, a link to a place where people gamble, and said, if you can push the narrative of it being technological, I would make more money. And I said, look, I don't care about money, because if it ends up being technological, money would lose its meaning. Instead of us investing $2.4 trillion in military budgets, as we are doing right now, we will start investing in space exploration. There will need to be some array of interceptors or sensors that warn us on Earth of any potential threats that come from outside the solar system. And it will change the way we think about our future. For example, we might realize that instead of engaging in conflicts, if you just look at the news every day, most of the money, most of the energy is focused on conflicts between people. But we're just like kids playing in a sandbox and arguing and mud wrestling and doing all kinds of things. And then if there was a visitor coming in and much more capable than we are, those kids would look at the visitor and realize, oh, wait a minute, we are all in the same boat. We have to work together. And so my hope is that the humans will come together, that we will change our priorities. Yeah. And of course, it will have huge philosophical implications as to our place in the universe. The fact that we have siblings, there was a group of religious theologians from an organization called Christianity Today that visited me at Harvard. And they asked, if we discover extraterrestrials, would it shake any of our beliefs, religious beliefs? And I said, look, I have two daughters. And when the second one was born, it didn't take away any of the love that I have to the first one. So if you imagine that God can attend, like a parent that can attend only to one child, that is very diminishing, of the image of God. We could have a lot of siblings and God would love all of them. And the only thing is, we might be jealous at another, at a sibling that is more accomplished than we are, but that's just a psychological problem that we might have that our therapist can help us with. So they agreed that it shouldn't be a threat to religion, that in fact there could be a lot of intelligent civilizations out there. And my guess, if you ask me the question of Enrico Fermi, where is everybody? You can ask the same question about all the people that used to live on Earth. There were 117 billion people that lived on Earth over the past few million years. And the answer is dead. Most of them are dead. We only have 8 billion that are alive. And the same is probably true for intelligent civilizations. Most of them are dead in the Milky Way galaxy. But if they ever ventured into space and they left some space probes, then we can find those. And it's very different. There is the Drake equation that you might be familiar with, searching for radio signals. Searching for radio signals, to detect a signal, you need someone to transmit the signal at the right time. And it's just like waiting for a phone call. Nobody may call you. You're living in a house and you see a lot of similar houses on the street. So we see, we think that, scientifically speaking, that there are billions of Earth-Sun analogs in the Milky Way galaxy, like many houses on the street. And we are waiting for a phone call from a house on the street. It may never happen when we are waiting. Nobody may call you from your street. But every now and then you might find a tennis ball that was thrown by a neighbor, or you might find a package that arrived in the mailbox a long time ago. And so the neighbor doesn't need to be alive when the package is found. A neighbor might show up in your front door. And these are very different possibilities than waiting for a radio signal. And the Drake equation quantifies the likelihood of us receiving a radio signal. But the Loeb scale that we discussed has nothing to do with the Drake. You can imagine a scenario where there are no radio transmissions, either because radio technology is old and they use something else for communication, or because they're dead, so you won't get any signal from them right now. But the Loeb scale talks about whatever they produced in space that may arrive to our backyard, and you can get a signal there. You can see and discover that we are not alone, while you are not detecting any signal. When the Drake equation gives you 0, you can still find an object that is 10 on the Loeb scale. So it's a very different approach. And you may think that the SETI community that was engaged for 7 decades in thinking about how to find intelligence elsewhere, that they would be cheering and saying, great, Avi, we support you. Not at all. They are very hostile.
That's crazy.
It's crazy.
I mean, you're head of this Galileo project, which is exactly about that. I mean, looking for searching for evidence of technological artifacts out there.
Yeah, and in fact, we built 3 observatories, one in Massachusetts, another one in Pennsylvania, and now we are completing next week, actually, an observatory in Nevada. And they will give us data on a few million objects in the sky. And we use machine learning software, artificial intelligence, to figure out if any of them is an outlier that is not human-made or natural. And so that is the way science is done. And at the time being, the SETI community had a committee that decided not to discuss objects near Earth that are called unidentified, not to allow that discussion in any of the conferences that they're hosting. Can you believe that?
No, it's
however,
difficult to believe,
however, I should say, 2 weeks ago, they posted a paper on the archive, on the preprint server online in astronomy, in which they said interstellar objects should be looked at for technological signature. The first paper, and they say that. And after seeing them attacking me just weeks before that, they were attacking me personally. One of them had a blog in which he was continuously saying bad things about me. And I did not respond, by the way. I was asked why. And I said, well, because I don't want to mud wrestle. You know, if you mud wrestle with other people, everyone gets dirty. I don't want to do that. Eventually, as I said before, if we are visited by a technological gadget, the data will show it. I don't need to argue with this blogger who, for some reason, wants to be in the limelight by attacking me. But that blogger ended up being a co-author on this paper with a few other co-authors. And they said, yeah, we should examine interstellar objects for technological signatures. And all I can say about that is what Oscar Wilde said. He said, imitation is the sincerest form of flattery. So I take it as a compliment.
That's true. Well, Oscar Wilde said so many good things, and wise things, and true things. But here's a question for you now. I mean, it's talking about looking out there and speaking about these objects being physical and coming maybe slowly here and maybe being, I don't know, threatening us and all that. I mean, you're looking out there into the skies, but why not? Why look out there and why not look right here? Maybe non-human intelligence has been here on Earth all along. As you know, many people are speculating. Maybe it's a dimensional thing. Maybe it's, quantum entanglement is a sign that an indication that there are no distances in the underlying reality, and all those woo-woo things that you can ponder. Maybe more advanced beings can master these things and can master dimensional travel. I mean, maybe it's not about looking for physical objects hurling through our solar system, if you see, what I mean.
So on those possibilities,
unpack that if you can.
Yeah. So I wanted to say I'm relatively down to earth.
Yeah.
Okay. In the following sense, that I don't enjoy science fiction. I never liked science fiction because very often the narrative violates the laws of physics. Now, I know the laws of physics. I teach them to my students. Okay, so we don't know that extra dimensions exist. There is a community of that worked for 50 years on extra dimensions in the context of string theory, and they can claim that they carry the torch of physics forward by trying to unify quantum mechanics and gravity. There is no shred of evidence to support the idea that there are more than 3 spatial dimensions. But nevertheless, they invested 50 years, very advanced mathematics, and they convince each other that they're smart. But my point is that science is not about convincing your peers that you are smart. It's about understanding the physical reality that we live in. And that should be guided by evidence. So when we see anomalies, that's when we start wondering what could explain them. One thing we don't understand, by the way, at a fundamental level is quantum mechanics.
Yeah.
So these string theories are jumping into extra dimensions, but we don't know how to interpret quantum mechanics. It's a very fundamental, we know how to calculate quantum mechanics, but we don't have a mental picture of how it works because we are classical objects, with our brains, we can't really figure it out. And it's quite possible that when you deal with quantum mechanics and gravity, there are things that we currently don't fully appreciate. For example, we don't know what most of the matter in the universe is. We don't know what most of the energy in the universe is. We call it dark matter, dark energy. And both of them may be manifestations of our ignorance about how quantum mechanics and gravity operate. Okay? And it's quite possible, but it may not have nothing to do with extra dimensions. So when people talk about extra dimensions, I tell them, look, but like if you were to say that 100 years ago that you can unify quantum mechanics and gravity by extra dimensions, people will ignore you. It sounds crazy, right? So, but we still don't have evidence. So why consider that as the prominent thesis? And by the way, here you see a contradiction, that you have the entire mainstream of theoretical physics adopting this notion of extra dimensions that we've never seen evidence for, and that is completely acceptable. You can be the adult in the room talking about extra dimensions. However, if you say an anomalous interstellar object might be technological, that is considered heresy.
Yeah.
And I like, again, it's not
interesting.
Yeah.
Really,
but coming back, the other thing that you mentioned is, of course, there could be visitors that are on Earth, or actually materials that were delivered to Earth from interstellar space, because every now and then an object will collide with Earth, on some random trajectory, and that would appear as a meteor. And in fact, in 2014, US government satellites spotted a meteor that was moving at a speed that implies that the object was not bound to the sun. It came from outside the solar system. And together with my student, we discovered it, but then the US Space Command confirmed it, because my colleagues were arguing they don't believe the US government. So the Department of Defense, the US Space Command, looked into the data and confirmed that it was interstellar. And I actually led an expedition to the Pacific Ocean to look for the materials from this object to figure out its nature. And there will be a Netflix documentary coming up, hopefully in 2026, that will show that expedition. That is another way by which we can learn about interstellar objects if they happen to collide with Earth. Just think about Voyager, the spacecraft that we launched to interstellar space. In 1 billion years, it will be opposite to the position of the sun relative to the Milky Way galaxy's center. So it could collide with a planet out there, and it would appear as a meteor, but only if there is a curious scientist willing to entertain the possibility that not everything in the sky is rocks. Only then that civilization would figure out that, Voyager is not a rock. It's actually technological in origin.
Yeah. I mean, since we're being a bit philosophical here, I have a question for you about what might have happened in deep history. You wrote in one of your essays, you had a speculation there which was very fascinating. You floated the idea that the development of Homo sapiens might at some point in deep history have had interstellar assistance, perhaps. At some point, you were referencing a study that showed that there is a 14.9 total genetic difference between chimps and humans. And you said that we should study this difference to see if maybe there was some kind of interstellar assistance, or whatever you want to call it. Can you elaborate on that?
Yeah. Well, there are two things to consider potentially when we study our history on Earth. One is we tend to think that we are first. Okay, so we are the first to develop advanced technologies. But that may not be true. There may have been, if you go back 100 million years, 200 million years, there may have been a civilization that is fairly advanced, and then there was some catastrophe, like a meteor impact, an asteroid impact, like the one that killed the dinosaurs, right? So if there was a major extinction event, it would have destroyed that civilization if it happened hundreds of millions of years ago. And by the way, 200 million years ago, that's just 5% of the age of the Earth. So instead of us appearing 100% the age of the Earth, it was 95%. That's, I think, completely plausible that intelligence could have emerged, or technology could have emerged earlier, by 5% earlier. And then if there was some catastrophe, either they kill themselves, as we are trying to do very on a daily basis, either through a world war or through a climate change or whatever they did. By the way, I'm never worried about Earth. Earth can always survive. Yeah. It's humanity that you have to worry about, because Earth went through a lot of catastrophes.
Yes.
And so at any event, Earth recovered. Eventually, life continued for other species. And the question is whether there was an intelligent technological civilization before us, hundreds of millions of years ago. And it would be difficult to find the remains if it was localized, and if the materials, I mean, the buildings, the digital screens, whatever they produced, might be buried under the surface of the Earth, because there was a lot of geological activity since then. And who knows what this catastrophe did also. So that's one question. Are we really the first one?
Yeah. Mm-hmm.
Yes. And of course, if they had satellites, or if they produced technological objects that are around us today that represent technologies well beyond what we possess, that may appear as unidentified anomalous phenomena. These are things that we don't fully understand because they are not natural, they're technological, and theory, they somehow survived. They somehow survived, and we can find them if we are sufficiently open-minded. But the second possibility that you mentioned is that we were visited. Again, that's not an original idea. That a lot of people raise the question of how did the Egyptians build the pyramids, and how did the...
Tell me about it. Yeah, this is a good rabbit hole that I've been
So at any event, there is this possibility that even the human genome was somehow planted by an interstellar gardener that visited the Earth and put it, made some modifications to the DNA of chimpanzees. And one way to find out is to see some abrupt change in the history of the DNA, if we can trace it.
Well, are you familiar with chromosome number 2, for instance, which is a bit strange? It looks as if it had been fused from two chromosomes.
Yeah, I'm not an expert on these matters, but I think it's very interesting to do the equivalent of archaeology in the context of genetic dating and history of the human genome. One thing that is widely believed, is that all forms of life on Earth originated from a common ancestor. It's called Luca, the last universal common ancestor. And by the way, this one as well could have been delivered from Mars on a rock, because Mars is a smaller body, had a larger surface area per unit mass. So, usually the amount of heat when you make an object is proportional to the mass, and the loss of heat from the object is proportional to the surface area. So a small object is losing more quickly the heat contained inside of it. So Mars cooled before Earth because it's smaller than Earth. And it could have been the case that Mars developed life before Earth, and that then life came from Mars to Earth in a rock. That
NASA just the other day announced that they had found life on Mars.
Well, they found signatures that are
quote unquote life,
with the microbial activity.
Signature,
But to figure out whether it's not geological, what they need is to bring a sample back to Earth. And of course, now it's a good timing for them to advocate that, because there are budget cuts, and NASA needs a boost to the science program. And my hope is that this will be funded, because then when these materials that were collected by the Perseverance rover are delivered to Earth, and if we find out within the coming decade that definitely there were microbes on Mars, which sounds very reasonable since it had liquid water, had lakes, oceans, rivers, just like Earth, then there will be a second place that we find life. And it would give a boost to the search for extraterrestrial life. But for me, as far as I'm concerned, microbes are boring compared to intelligent beings, because we can learn from intelligent beings. much more, and it would change a lot of things for us in our future, and we could develop new technologies that we've never dreamed of and learn new science that we've never studied if we discover extraterrestrial intelligence.
So what I have to ask you about the ongoing disclosure process in the UAP disclosure process. And there was a hearing, the third hearing in Congress, in the United States Congress, last Tuesday, September 9th. And so what is your take on what's happening there? You mentioned this theory that these things that people are seeing might be perhaps probes or satellites from a very distant ancient civilization that lived on Earth. Or what's your take on the whole process that's going on here? I know you've had contact with Congresswoman Luna as well, who is leading this.
So I'm intrigued by those reports. I'm intrigued by the data. I don't know if the US government has information or materials that indicate something extremely unusual, because I was never presented that. There are people with stories, but I take the approach of the FIFA, the Soccer World Organization. FIFA, when they try to decide if there was a controversial goal, they are not asking the players. They don't go around and ask the goalkeeper or the audience. They don't ask people. They just look at the data, the video data from the cameras. And that's what the Galileo Project is doing. The Galileo Project is building observatories to look around and collect scientific quality data, analyze it with machine learning in the scientific way. And if we find anything anomalous, you will hear about it, and it will be validated by the scientific method. I don't care about what people say, because we know that people sometimes believe stories that are untrue. In fact, that happens very often. And one thing I told students in my class is the legal system is very different than physics. The legal system has laws, but people often break them. Electrons in the entire universe follow the same laws of physics. There is no electron that could break the laws of physics. Okay, if you find such an electron, you will get the Nobel Prize. And the other difference is that in the legal system, people can be absolutely sure that something happened and testify about it, and that is taken as evidence. In doing physics, science, I don't care what people say. This is completely irrelevant, because people have wishful thinking. They have a hidden agenda. When there is a car accident, you get very different reports from different people involved. I just want to get data from instruments and figure it out. So that's the approach of the Galileo Project. And I actually presented the project on May 1st, 2025, in a congressional briefing. That's where I met Representative Luna. And we resonated in the sense that she is curious and she wants to figure out if government has information that is being hidden from scientists. And as a scientist, I really want to help government figure it out if they have it. But I'm not waiting for government to tell me, because what lies outside the solar system is not the jurisdiction of government. They're supposed to worry about national security. And I, as a scientist, I'm not interested in what humans produce. I really want to find if there is anything else. And so we have complementary interests. The government is interested in one thing. I'm interested. Now, it's possible they collected data because they keep looking at the sky for national security purposes. They may have data that suggests something from outside the solar system, and I would love to see it and help them figure it out if they have it. And so that's where the overlap is. But with the Galileo Project, I'm just following the scientific method, and I don't ignore it, because even if it turns out that all these anomalous objects were produced by humans, by adversarial nations.
Very interesting, right?
I think it's still very important. So I would be happy to give my set of sensors and algorithms for analyzing data to the Department of Defense, because it will help protect the nation against adversarial nations. And I would not feel that my time was wasted. And however, there is no other organized scientific team doing the same thing as the Galileo Project. The only thing that happened outside the Galileo Project was a recommendation from NASA to do such research, but they never funded it. And gladly I get support from foundations or private donors that allow the Galileo Project to proceed and collect data, and we should see what we find. But it's basically taking this subject seriously and approaching it scientifically. I think that's the obligation of scientists. I think scientists should attend to the interests of the society that they live in.
Absolutely.
And there are two interests. One is national security. So if we help protect the nation, we did an important service to the nation, right? And the second is to address a question that the public cares about. And believe me, the question is, are we alone? That is the question that the public cares most about. And I can prove it by the fact that I have non-stop requests for interviews, for people to speak. I get hundreds of emails every day from people who are really excited about the science. And how often do you get, the daughter of a U.S. Air Force pilot to say, I want to become a scientist? Even if CERN, were to discover a new particle in the Large Hadron Collider, I'm doubtful that this would inspire a young kid and however, for some reason, this question of are we alone, are there extraterrestrials, that sparks the imagination.
Yes,
that's
one of the biggest questions everybody has, of course.
Yeah, and it's a question that we can address with the modern scientific tools. So it's a missed opportunity for the mainstream of science to say, no. We want to do fancy math and intellectual gymnastics about extra dimensions, and that will be worked on by thousands of particle physicists for 50 years. While in the context of astrobiology, we will invest more than $10 billion in building the next space observatory that is called the Habitable World Observatory over the next 2 decades in search for microbes in the atmospheres of 25 planets. That's it. And we will give we recommend zero federal funding as of now to the search for intelligence. And I say something is wrong here.
That's crazy.
Because we should hedge our bets. You might say microbes are much more abundant, and it's the same as looking at the houses on the street and saying, oh, surely they have microbes, but good luck. Try to find evidence for the microbes by having a telescope looking through the window of your home. It's really difficult to detect microbes in other houses from a distance. That's what we are trying to do with exoplanets. And I say, if those houses have one resident in the entire street, you might actually get a tennis ball in your backyard. You might actually get the privilege of a visit by that resident, or you might see a construction project in the yard that the resident is in, and that will tell you much more easily that there is a resident. You might even not need a telescope. You could see a construction project. And so even though intelligent beings might be much rarer than microbes, they might be much easier to detect. Yes. And this is, again, common sense. So we should hedge our bets. We should put billions of dollars to the search for microbes. I have nothing against that. But at the same time, billions of dollars to the search for intelligence. And that is not done.
Yes, let's hope for that. Let's cross our fingers. You have mentioned that you have been attacked in academia, but I wonder, are some of your colleagues perhaps giving you a thumbs up behind the scenes, as it were?
Yeah, everyone that knows me is very supportive because they know where I come from. I started in cosmology, studying the universe, and we don't know what most of the matter is. We call it dark matter. And so the mentality of practitioners there, I should say they are closer to chess players. Okay, so people who do cosmology are like chess players. People who work on rocks, like the comet experts, are more like mud wrestlers. It's a different job. So in the context of cosmology, my experience, that was my training among all these chess players. It was people were happy and encouraging. If you were to come with a proposal for what the dark matter is, they would be happy because then experimentalists can pursue that and look for the signatures of the type of dark matter that you suggested. And there was never an organization that would say, okay, we believe in weakly interacting massive particles. We will not allow any discussion about axions as the dark matter or primordial black holes as the dark. That never happened, as it does, as I said before, with the SETI community. They don't want to hear about objects, just about electromagnetic signals or microbes. That's it. And so it's a very different culture. I came from that culture where if we don't know something, if there's something anomalous, like the matter in the universe that is not visible to us, this is an anomaly. And figuring out the meaning of it is, you're searching in the dark. And if you are searching in the dark and you tell the entire crowd, you should all work on one thing, which is along a certain path. So everyone goes along the same path. And whenever someone deviates from the herd, you bring that person back to the herd so that you maintain a tight configuration of the herd that goes along that path. On the one hand, you might be lucky and find what dark matter is, but what really happened over the past 40 years is that the mainstream community of cosmology thought, the dark matter is most likely weakly interacting massive particles, the lightest supersymmetric particle. And then when the Large Hadron Collider at a cost of $10 billion didn't find supersymmetry, they said, okay, that is ruled out, and now we have tight limits. Now, it's not a waste of time or effort, but my point is we should allow different scientists to explore different paths, because we never know where the truth lies, what describes reality. And the scientific endeavor would be more efficient if we allow diversity of opinions, diversity of ideas, if we encourage that. But instead, what do I see? When I try to advocate for the search for technological signatures, I get attacked personally. And that to me is a sign of dogmatists, people who don't want, or people who are jealous of the public attention. So when I talk about it, the public cares a lot about it, and I get a lot of interest. And of course, some people in academia get jealous. And the way for them to feel less jealous is by trying to bring me down. Okay? It's like basically stepping on any flower that rises above the grass level. And this is a common practice in academia. And it's very dangerous, not so much, obviously it suppresses innovation because people are afraid to deviate from the herd, but the groupthink. But also it sends a signal to young people. Young people often are exploring new territories and they have new ideas. But when they see a person as senior as I am being attacked, they say, well, I need to get a job. I better not deviate from the beaten path because I would risk my job prospects. And that's the worst damage that can be inflicted by those attacks. Basically discouraging young people from deviating from popular view and exploring the unknown in new ways. And, that may explain why the discovery rate right now is lower than it was 95 years ago when quantum mechanics was discovered. And by the way, we now have many more scientists. So you might say the efficiency should have been larger for discovering things. But having a large community actually creates social pressure, peer pressure on doing the same thing. It's like regression to the mean. In statistics, if you have a large enough population, it's well defined by a Gaussian distribution with a very tight variance, the larger the number of people is. And so
the production, the creative outcome will be kind of in the middle of everybody.
Yeah, it's called regression to the
regression
mean.
to the mean.
Yes. That's why I hate big committees.
Yeah.
Because in a big committee, you're basically regressing to the mean opinion, which is not necessarily the correct one.
Professor Loeb, have you always walked your own path? Were you a curious and inquisitive child? Have you always been like a bit of an outlier?
Yeah, so the one surprise throughout my life was I'm trying to advocate what sounds to me like common sense. And very often it turns out that I'm an outlier. And I don't understand that. It's not as if I planned that. But the point is, I would not have a tenured appointment at Harvard if everyone would think like me. And, when I started astrophysics, my first mentor, John Bacall, asked me, what kind of computer languages do you master? That was 1986, when I was just about to finish my PhD. And I said, look, I'm just using computers to solve differential equations. I don't really care about computers. And I just, whenever I have an equation that I need to solve, I would use the computer, but I will just learn what I need in order to solve that equation. So I don't care more than that. He said, well, how do you think you will have a successful career? That was 1986. And nevertheless, I was tenured at Harvard after 3 years. Now, how do I explain that? It's because other people are not thinking like me. And that's a miracle to me. I mean, it cannot be planned. I mean, I think the way that, sounds to me like down to earth, simple-minded, and apparently a lot of people in the public accept that. But the fact that a lot of people in academia do not think that way is a surprise. And that's what allowed me to have a successful career. Because if everyone would think like me, there were, hundreds of Avi Loebs in academia, nobody would notice me. And I would not have computer skills to distinguish myself from the others.
Right. Professor Avi Loeb, it has been a fantastic conversation. I know that you need to go now, and we've talked for a long time. Fascinating conversation. I will make sure to put links to the Galileo Project and to your Medium site there. Fantastic essays that I recommend everybody to read, and other relevant work. I will put links to that in the description. So thank you so much for taking the time, and good luck with your important and fascinating exploration.
Thanks for having me. It was a real pleasure.
Hello, my friends. If you like this video, don't forget to subscribe, and don't forget to hit that like button and share the video with your friends. Please support the channel if you can. I appreciate all the support. All the links are in the description box below. Thank you.